Okay, guys, this is the sort of review video for the Unit 5 stats test that's on sampling distributions. So I just want to start with the notes in case you missed it from class or you weren't there, just so what these things are. So parameter is, in really basic terms, is a number about population. Okay, so like what that means is, right, if my population is all sum of students, like let's say 3% of all summit, all students, so to say, all students live in San Carlos, for example, right? So that would be the parameter because it's all students. Like that's the key. That's the population. Whereas for statistic, let me zoom out a little bit. Statistic, that is a number about a sample. Okay. So, for example, like 5% of Mr. Kelly's class live in San Carlos, like, for example, right? So this right here is like that's a sample, right? That's sample because it's smaller, whereas all students that's the population. Okay, so if it's about the population, it's parameter. If it's a statistic, it's sample. And an easy way to remember that is because they start with the same letter. Z-score really simply is number of standard deviations from mean. The equation for it is just x minus mu over sigma, where this is the standard deviation, this is the mean, and this is the value. Okay, and we'll go through some example of using that. For these two proportions, this is like p. This is but percentages. Really, is what this is saying. The mean of the sample proportions, that's the mean of the p hat, is equal to the original population proportion. So equals population proportion. The standard deviation is the square root of p times 1 minus p all divided by n. Okay. That is the standard deviation. This is the sigma, right? And over here, the mean of if it's means, right, this should be sample mean here, by the way. It should be mean. Should be mean. We're dealing with means. We're not dealing with percentages. Over here, the mean, the sample mean is equal to the population mean, and this right here just means sample mean. Basically, it's the same as the other one. It means the same thing. Like it's the same as the original. And the standard deviation is used by S, and that's sigma over square root of n. Okay, so really, this is the only thing you have to change when you go to take the standard deviation of the sample proportion or sample mean. You have to use these equations. So I'm going to use them as we do the practice test. We start basic. This is straight from Delta 5.1, and that's a z-score equation. That's just x minus mu over the sigma. That's this z-score equation. So again, you have the mean, you have the value, you have the standard deviation. So I'll go ahead and do these. Basically, by reading the question here, you can see that 270 is your x, 300 is your mean, and 20 is your standard deviation. When you find it, it comes out to negative 1.5. That's it. You're done. Okay. Here, your value is 315. The mean is 300. Standard deviation is 20. So that 15 over 20 is 3/4 or 0.75. Okay. And same thing here. It's 230 minus 300 over 25 equals negative 70. Negative 70 over 25 in the calculator. That is negative 2.8. Okay. That's just z-score. Easy, right? Just find and plug in. Next part, you have to do that. You have to find the z-score, and then there's another step. It's a second step. And I'll talk about that. Let me try and get rid of that shadow. Let's see. Okay. So this is probability. So again, z-scores can be negative or positive. No issue there. Probabilities have to be positive. We'll talk about that. So the first step here is unifying the z-score. The z-score for this one is going to be 32 minus 32 over 3. This actually just comes out to 0. So my z-score is 0. Then to find the probability, you go to the table and you're going to look for 0. So this is 0 here and 0 here. It's exactly 50%. And that makes sense, right? Because you think visually, the 0, if you think about the standard deviation, is right in the middle. So it makes sense that this area here is 50%. Okay, so that's 0.5. 5. Okay. Continuing, same thing here. We have 131 minus 125 over 5. That is 6 over 5, which is 1.2. Right? This is my x value. That is my mean. That is my standard deviation. And I'm just plugging them into the standard deviation formula, z-score. And then I want to go find this in the table. So it's 1.2. So I'm going to find 1.2. And I get this value right here, 0.8849. It's not this one. Is that clear? It's right here. Okay. However, that's giving me less than. And I actually want higher. See how it says higher here? On the z table, you're always getting the less than. Always, let's see how it's shaded to the left. So this is the probability of it being less than 1.2 standard deviations. I actually want greater than. So to find that, I do 1 minus it. So probably is going to be 1 minus 0.8849, which is 0.1151. That's the answer. I want to note if it says less than, like the one above. See how the other one said shorter or less, like less, right? You just read the number as it is. You don't need to do anything to it. If it says higher, you do 1 minus the value. Or more than, it's 1 minus the whatever the z table says. Okay? All right, continuing on. This is a conceptual. A sports writer took samples of 30 baseball players and found the mean annual salary for each sample. He got the following sampling distribution measured in millions of dollars. What does each dot represent? So each dot here does not represent a baseball player. It represents a sample of 30. So each dot is the average of 30 player salaries. Okay? Each one is an average. Each one is a sample. That's key, right? Sample mean. Think of it like that. The true mean salary, well, estimating the center of this data, I guess, looks around like right this mark. So I'd say 4.2 million. And I would take something in that ballpark. It doesn't have to be right 4.2, 4.3. It's definitely in the center right here. 4.5 even. Okay. Next, according to the U.S. Census, 24% of people in Redwood City are under 18 years old. We random select 50 people and find that 27% are under 18. what's the parameter? So remember, parameter from the notes is about population. So which one of these is about the population? Well, people in Redwood City, this is the pop. That's the population. And this randomly selected 50 people, that's the sample, right? So therefore, this 24% must be the parameter, and this 27% must be the the statistic, right? So 24% parameter, 27% is the statistics, and the statistic and the sample size is 50. And we're dealing with proportions because percentages, right? Percentages. That's the key. Percentages indicate proportions. Moving on. Number 3. Mr. Kelly believes that 45% of some students prefer AB schedule. He randomly samples 500 of the 4,095 students at schools and asks whether they like it. From now on, assume all conditions are met. Find the mean and standard deviation of the sampling distribution. So this is going back to our notes that we just took. So the first question you want to ask yourself is, am I dealing with proportion or am I dealing with a mean? And I know that I'm dealing with a proportion here because of this percentage. So this is like, okay, proportion. So if I think about my notes, I'm using this, see where it says proportions right here? I'm using these right here. So the mean of the sample proportion is equal to the original. So my original proportion was 45%, so my mean is 0.45. Standard deviation, I'm going to use this equation. The square root of, right here, square root of p times 1 minus p over n. So we write it out. Let's write it out first. I'm going to write out just a plain equation. It's going to be p 1 minus p all over n. And this is, so my p is, I'll write this up above here, p is 0.45. And my n is 500. I know my n is 500 because my sample size is 500. I took 500 of the students, so therefore n is 500, right? So then I'm going to do square root. It's going to be 0.45 times 0.55 over 500. And we're going to take the square root of that. And this is going to come out to, right down below here, 0.45 times 0.55 divided by 500 square rooted is 0.022 roughly. So that is my standard deviation. B, I don't want you to worry about B too much. Basically, it means that roughly, 95% of the data is within 0.044 plus minus 0.044 from the mean. That's roughly what that means. But I don't want you to worry about B right now. That's what I want to see. What's the probability that she gets a sample where less than 42% of the students prefer AB schedule? So you need to find the z-score, just like we did in the warm-up in the first page, and then the probability. So for z-score, it's the same formula. It's x minus the mean over sigma. Now, even though the symbols are kind of different, it's the same principle. We have our mean is this one. This is our true mean that we found. That's our 0.45. That's our sampling mean. So that's going to be my mu. And then my x value, the value that I'm looking for, right, is this less than 42%. So it's going to be 0.42 minus 0.45, and then divided by my standard deviation that I found, 0.022. Okay, so we'll do this in the 0.42 minus 0.45 divided by 0.022 is negative 1.36. That's my z-score. Then I want less than this. So what I do is go to the z-table, and I'm going to go to the negative side. I'm going to go to negative 1.3 is right here. And this is 1.30. 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5, 6. This is it right here. Okay. So 0.0869. That is our probability. Yeah. Basically, there is a roughly 8%, 8.5%, 9% chance that it's a sample less than 42%. It's pretty unlikely, right? Okay. We're on the last page now. So we're on page 4. We're going to skip over. A machine produces candy bars with a mean weight of 0.1.55 and a population standard deviation of 0.05 ounces. The population is not a normal distribution. To test the machine, a candy company checks the first 2035 bars out of the 4,000 they produce each day. From now on, assume all conditions are met, find the mean and standard deviation of the sampling distribution. So the mean, so now, it's again, same thing. Are we using proportions or are we using means? Well, this is the mean because there's no percentages involved, right? We're dealing with sample means. So I'm going to use that one. So remember, the mean of the sample one is the same as the mean as the original. So this is just 1.55. It's easy, 1.55. Okay. Standard deviation. This is equal to, remember, so this is like x bar is the notation. It's okay if you don't write that, but just so you know, the standard deviation is equal to that population divided by the square root of n. So my population standard deviation was 0.05. I'm going to divide that by the square root of 35. When I do that, I'm going to get a calculator. 0.05 divided by square root 35 equals 0.008485, basically. 0.0085. So I'm just plugging in the values into the equation, right? This equation. My sigma, this is my sigma right here, this 0.005, because that's the population standard deviation. This is the sigma. Let me just label that. This is my mean, right? This is the mu. And then right here is 35. That's my n. That's my sample size. So I guess let's see what I did here with like the circling and the labeling. I really recommend that you do something like that on your test or on your practice test, right? We're going to skip B. We're going to move to C and D. Find the Z-score. So you're pretty used to this by now. The confusing thing about this one is that it's mentioning, like, this also says that this is a mean, but it's like, this is like, imagine, think of this like, this is the mean of our means. This is like this represents like the center of everything. This is really the mean, right? This is true mean in the Z equation like context. So it's going to be something minus 1.55, and obviously our standard deviation that we're using is 0.0085, and then our value that we're comparing is just 1.51. Okay, so we plug that in. 1.51 minus 1.55 divided by 0.0085. It's a pretty big number. It's 1.51 minus 1.55 divided by 0.008. It's roughly -5. Okay, it's roughly -5. This is kind of a special z-score. If you look at your z-score sheet, you're actually not gonna get to -5 if you keep going. So going down, you see we don't really get past -3.4 here, but there are some special ones over the sides. You see this -5 right here. This is that area. So this is the area to the left of -5 with the probability of being less than 5 standard deviations away from the mean. But I want here, if you notice, I want greater. So for this one, it's going to be 1 minus, and I'm going to subtract this probability right here. So it's going to be kind of a long number. It's 0.000000287, which comes out to 1 minus 0.000000287 is 0.999999713. So I mean, this is technically the correct answer. On the test, I'm not gonna give you something crazy like -5. It's gonna be more of a standard number that you're gonna find in this center here. Okay, and that is it. That is the practice test. Good luck on Friday.